Be strong.
Hey guys, welcome back to IGCSE Math Syllabus 0580, Episode 3. So today we will be covering about algebra. So introduction to algebra. And if you haven't watched the previous video, then I suggest you to watch it. And later on you can come back to this video. Okay, so table of contents. Okay, so first of all, so what is algebra? Okay, so I have an example of daily life that is an example of algebra. Okay, so for example here we have a person. Okay, let's just say Tom. Okay, Tom is sad because someone stole his cookies. Okay, so he was having a basket of cookies that is 10. Okay, so he has 10 cookies in a basket and someone stole it. Okay, so the thief steals some cookies. Okay, we do not know how did he steal, but he stole some cookies. Later on, Tom discovered that there are only 5 cookies left in the basket. Okay, so algebra is basically learning about undefined quantity that we want to know. Okay, so here we do not know how many cookies did the thief steal, but since we already know that the that he was having 10 and now he has 5, Tom has 5 cookies, so we can work out this the number of cookies that the thief steals. Okay, so basically algebra is one of the branch of mathematics that involves in solving unknown quantity. Okay, and then next, what is variable? So variable first is an unknown quantity that is written in alphabets. Okay, so we would represent the unknown quantity with the alphabet. So example, we can represent it in X or Y, which is the most common, but we can also represent it in A, B, C. Okay, so C, D, in any alphabet we can represent the value. Okay, next one. So Alan has some apples. Okay, so for example, Alan has some apples. We don't know how many apples. That's why some can be written as a variable in math. So for example, Alan has X apples. So X here can be represented as the quantity that we want, that we don't know. Okay, so note, a variable can also have power or indices. Example, x squared and y cubed. Okay, next one. So what is coefficient? So here I have an example. If you have some amount of balls in a cart, so for example here we don't know, let's just say that we don't know the quantity of this ball. Okay, so let's say there is x balls. Okay, x represent the unknown quantity, and then also we have another card that is the same amount, so we'll say x balls as well. Okay, so since we have two cards, okay, and they both have the same amount, which is x, we can write as 2x. Okay, 2x balls, and this is basically the coefficient. Okay, which is the multiply of a variable. Okay, so it comes in front of the variable, so to the left of the variable. Okay, and later on we will see many examples regarding coefficient. So term and expression 2.3. So what is term? So a term can be variables, coefficient, and variable itself. Okay, or just a number. A term can be. So what is term? So term can be variables, coefficient, and variables, or just a number. Okay, so it can be variables. So for example, x. So this we can call it as a term, and coefficient and variable, so let's say 3y, this is also a term or just a number, like for example 4. Okay, but you can sometimes see a term separated by positive or negative. See, each term is separated by addition or subtraction. An expression has more than one term. Okay, so for example, expression has more than one term. So this, if you have 3x plus 5, so each of these is a term, but all of this is an expression. Okay, this is expression, this is a term. So 6 rules of indices or powers, index law, multiplication indices. So here the rule is, the general rule if you have a squared, a to the power of something, so AC, okay, times a to the power of d. Okay, so if you have a to the power of something multiplied by a to the power of another thing, you can just add the powers. Okay, so you can add d and c, so it will be a to the power of c plus d. But this law can only be used when there is the same base, which is a, right? If we do not have the same base, like for example a to the power of c times b to the power of d. We cannot use this rule. Okay, so here there are some examples. So 5 to the power of 5 times 5 to the power of 3, which is 5 to the power of 5 plus 3. Okay, since we have the same base, so it will be 5 to the power of 8. Next one, 5 to the power of 5 times 5 squared. Okay, so same again, we have the same base, so it will be 5 to the power of 5 plus 2, so it will be 5 to the power of 7. Okay, this is the same, so same example. Now here we have different base, so we cannot use this formula. Okay, yes, we can use this, so it will be 4 to the power of 2 plus 5, it will be 4 to the 7th power, and then here, so notice that this is only 4, there is no powers, so what should we do? Okay, so in this case we'll just write 4 to the power of 1, since it's just the same as 4. Okay, so 1, so we have the same base, so it will be 1 plus 5, so 4 to the power of 1 plus 5, it will be 4 to the 6th power. Finally, 4 cubed times 4 to the power of 5. Okay, so here it will be just the same again, we will add, so it will be 4 to the 8th power. Now we have also division with indices. So here, if we have a to the power of something divided by a to the power of another thing, we can subtract the power, but just like previous law, we have to have the same base in order to subtract. Okay, so if we have a to the power of c divide, sometimes it will not be written as this or as this, it will be written as this. Okay, and just like the law, we have to subtract c minus d, since we have a as the common base. Okay, so the first example is 6 to the 6th power divided by 6 cubed. Okay, so we have 6, so it will be 6 to 6 minus 3, so it will be 6 cubed. Here we will do the same again, 6 minus 2, it will be 6 to the 4th power. Now here we cannot use this law because the base are different. Okay, so we cannot use this law. If you want to evaluate, you can do it. And then 5 to the 6th power divided by 5 squared, so it will be 5 to the 6 minus 2, so it will be 5 to the 4th power. Here, now notice in this case the left hand side, the left number has a bigger power. Okay, so just we will do the same again, 2 minus 6, but in this case it will be a negative indices or power. Okay, so it will be 5 to the power of negative 4, which means it will just be the same as 1 over 5 to the power of 4. Okay, negative means over. Okay, so So negative represent 1 over something. Okay, here, so we have the same base, so 5 minus to the power of negative 2 minus 6, so it will be 5 to the power of negative 8, which is the same as 1 over 5 to the power of 8, which is because negative power means 1 over. Okay, so if we have 8 to the power of 1, it will just be the same as 1 8. Okay, and then here we have the same base, so 5 to the power of 2 minus negative 6, so it will be positive, right? Negative and negative, it will be positive, so 5 to the power of 8. Okay, and we're done. So next one, so there is also brackets with indices or powers. So if we have a to the power of c, and you will do that also to the power of d, so it will just be the same as a to the power of c times d. Okay, so for example, 5 squared and then to the power of 3, so it will just be the same as 5 to the power of 2 times 3, which is 6. Okay, so it will be 5 to the power of 6, same as this one. So 8 to the power of 6 to the power of 4, so it will be 8 to the power of 6 times 4, which is 24. Okay, so a is to the power of 24. Now in this one, this is a little tough, so if you can solve this, I suggest you to pause the video and solve it first, and I'll solve it after some times. Okay, so in this example, in the top one we have the same as previous, but we also have over. Okay, so at the same time we have division. Okay, so what we will do is, it's easier to do the brackets first. Okay, so a squared to the power of 7, which is a 14, and then a divided by a to the power of 8. Okay, so in this example, over means division, so it will be the same as division. Okay, so it will be just the same as the division symbol, so a to the power of 14 divided by a to the power of 8, which is the same as a to the power of 14 minus 8. Okay, so it will be a to the power of 6. So in the next one is about negative indices, and basically if we have anything to the negative power or negative indices, you will write it 1 over the number. Okay, so for example, if we have, let's say 2 to the power of negative 1, then it will be the same as 1 over 2 to the power of 1. Okay, if we have 5 to the power of negative 2, it will be the same as 1 over 5 squared. Okay, so remember that negative means 1 over something. Okay, here we have 7 to the power of negative 2, it's just mean 1 over 7 squared, or 1 over 49. 4 to the power of negative 3, it will be the same as 1 over 4 cubed, or 1 over 64. In this case, okay, so this one we have negative 4 to the power of negative 2, it means 1 over negative 4 squared, which is the same as negative 1 over 16. Okay, and I want you to solve the rest. Pause the video first, and then I'll solve it after some times. Okay, so this one is 1 over 3 cube, which is 1 over 27. This one is 1 over 5 cube, which is 1 over 125. This is 1 over 36. This is 1 over negative 5 cube, which is the same as 1 over negative 125. This is negative 64, 100, 1 over 81, and here is 1 over 64. The last one is 1 over 21. I hope you get it right. So the next one is about addition or subtraction of indices. If you have a number, let's say a to the power of b plus a to the power of b again, we will write it as 2a to the power of b, because there is two of them, right? If we have 2 squared plus 2 squared, we will just write as 2 times 2 squared, because we have 2. Okay, and we have 4 cube plus 4 cube. We will not add the 3's because this is not multiple, but we will write it as, because we have 2 of these, we write as 2 times 4 cube. Okay, next one. Okay, so the last one is about prime factorization of number. So that means prime factorization means when a number is written in product of prime numbers. So we want a number and we want to write it in prime numbers where they multiply by each other and the result will be the number itself. Okay, so for example, write 60 in prime factor. Okay, so 60, we have to divide it in the lowest prime number, so which is 2. So 2 and 30, 2 again and 15, and then 15, since it's an odd number, we will divide it by 3. Okay, and then we get 5. So we will write it as 2 times 2 times 3 times 5. Okay, or 2 squared times 3 times 5. So this is 60 in prime factor. Okay, another example would be, let's say 80. So 80 divided by 2, it will be 40, divided by 2 again, it will be 20, divided by 2, it will be 10, divided by 2, it will be 5. Okay, so it will be 1, 2, 3, 4. So there is 2/4. I mean, there is 4 2's, so we will write it as 2 to the power of 4 times 5. Okay, so this is 80 in the form of prime factor. Okay guys, thanks for watching. Please subscribe, like and share this video. Follow me on Instagram, and see you guys later. Bye.